Good morning, students. Today we will start exercise 3.5. We are starting the lecture number 8 of this chapter number 3rd. So we will have to revise some basics again. Conditions for consistent, inconsistent. When we start this chapter, then we study this condition. So here we are having the three conditions. First, for unique solution, condition is if a1 upon a2 not equal to b1 upon b2, this is called consistent. Second, infinite many solution. If a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, then infinite many solution. This is also consistent. Third is no solution. If a1 upon a2 equal to b1 upon b2 but not equal to c1 upon c2, then we call it inconsistent. So already we discussed this basic before starting the 3.3 exercise. So now you should know that algebraical method we can apply only when solution is unique. Unique means generally we get one value of x and one value of y. If solution is infinite many or no, then it is not possible to find out the value of x and y. So if we study the question number first of this 3.5 exercise, then here is also written, which of the following pair of linear equation has unique solution, no solution, or infinitely many solution? In case there is unique solution, find it by using cross multiplication. So now we will study the cross multiplication method, but only when solution is unique. So let us take the first part. A1 means coefficient of x in first equation, A2 means coefficient of x in second equation. So A1 is 1, A2 is 3. So A1 upon A2, 1 upon 3. B1 and B2 are coefficient of y in first and second equation. So here A1 is minus 3, A2 is minus 9. So by solving this, we get 1 upon 3. Now C1 and C2 are constant values. C1 minus 3, C2 minus 2. So C1 upon C2 minus will cancel. It is 3 upon 2. So here A1 upon A2 and B1 upon B2 are equal, but C1 upon C2 is not equal. So this is the case of no solution. So this is the answer. We can't solve it further because here solution is no. Again I am revising. We can solve the question by any algebraical method when solution is unique. So let us see the second part now. Now we will see here that we can use cross multiplication or any algebraical method when solution is unique. This is the second part. A1 upon A2, 2 upon 3, B1 upon B2, 1 upon 2. So these two are not equal. If these two are not equal, then here solution is unique. Now we will solve this question by using cross multiplication method. This method we will study. Cross multiplication method. So first step of this method, that you try to take all the values in left hand side and right hand side you will remain with 0. 2x plus y as it is, this 5 will become minus, here is 0. 3x plus 2y as it is, this 8 will become minus, here is 0. Now we have to remember this formula 2312. 2 means coefficient of y, 3 means constant value, 1 means first value means coefficient of x, 2 mean again coefficient of y. Coefficient of x means first place, coefficient of y is second place, and constant is third place. So first, second value, then third value, then first value, then second value. So we will write x, y and 1 here. So x we will write in left hand side of x second value. Second value means 1 and 2. Here we will write. Then third value on this side of x. First we will write second value on left hand side of x. Then we write third value on right hand side of x, minus 5, minus 8. Now y, we already write second and third value. Now come to the first value, 2 and 3. Here we will write 2 and 3 on right hand side of 5. Then again second means 1 and 2, right hand side of 1. Again you see, we will write x, y, 1. First we will write second value, 1 and 2. Then we will write third value, minus 5, minus 8. Then we will write first value, 2 and 3. Then we write second value, 1 and 2. And we will now apply this sign of cross, because we have to multiply like this. So name of method is cross multiplication method. Only this is the reason of naming of this method. So x upon y upon 1 upon you have to write. So you just start to multiply 1 and minus 8, minus 8. Then from bottom to top, 2 into minus 5, it is minus 10. Always you have to change the sign of this second value. This is minus 10, so this will become plus 10. Equal y upon, again you will see, we will multiply like this, minus 5 and 3, minus 15. Now we multiply like this, minus 8 into 2, minus 16. We will change the sign again of second value. This is plus 16. So 1 upon 2 into 2, 4, 3 into 1, 3. Again we will change the sign. This is minus 3. So this is the main point, 23, 12. Then x, 10 minus 8, this is 2. Y, minus 15 plus 16, 1. 1, again here is 1. So let this is number 1, this is number 2, this is number 3. Now we will apply this line. First pair we will take of first and third. So x upon 2 here, 1 upon 1 here, cross multiply, value of x is 2. Now we will take second and third. So from second and third, y upon 1 equal to 1 upon 1, again cross multiply, value of y is 1. So we can solve the question by any algebraical method when solution is unique, otherwise no. Now let us come to the third part. In third part, a1 upon a2 we find out, this is 1 upon 2, then we find out b1 upon b2, this is 1 upon 2, then we find out c1 upon c2, this is also 1 upon 2. So all these three are equal. If all these three are equal, it means this is a case of infinite many solution. So when we start with first part, then there was no solution, we are not able to solve the question. Then we solve second part, solution is unique, we are able to solve this by any algebraical method, but here we apply cross multiplication. Then third part, we are having infinite many solution, again we are unable to solve this because we are able to solve the question only when solution is unique. So fourth part, this is the fourth part, this you have to solve yourself. So tomorrow we will solve the word problem of this exercise.